All right. So we'll continue with these pH problems. So when the H3O plus was 4.0 times 10 power negative 5, you plug that into the formula, take the negative log of that, and the number of sig figs should be 2 sig figs after the decimal point, so that gives you 4.40 as the pH of that solution. All right, what happens if you are given the pH and asked to find out the H3O plus? All right, then you have to do the reverse. That means you are going to do anti-log. Okay, so that anti-log takes this form: 10 to the negative pH. All right, so 10 raised to the negative pH. So 10 raised to negative 5, all right, that will give you an H3O plus of 1 times 10 to the negative 5, right? So that involves using what is called as a second function key, okay? So you would press second function and then the log key, and then you will get the answer, okay? All right, so also make sure about the sig figs when you determine the H3O plus, okay? Its number of sig figs should correspond to the number of sig figs after the decimal point in the pH value. Right, so here there's two sig figs after the decimal point. Therefore, your H3O plus should have a total of 2 sig figs, okay? All right, so 10 to the negative 3.42 will give you H3O plus. Okay. So how do you do this in your calculator? You press second function log, then punch in the number 3.42, then plus minus to convert it into a negative number, and then you get your calculator display. All right, you want to have your H3O plus to just 2 sig figs, so it's going to be 3.8 times 10 to the negative 4. So 3.8 times 10 to the negative 4. Alright, there's several ways to solve the pH problems. Alright, so first things, the simple definition is taking the negative log of the H plus or H3O plus, okay? Another way is if you're given the OH minus concentration, you can do POH, which is negative log of OH minus, okay? Now, pKw, as I said, is negative log of Kw, okay? So if you take the negative log of the Kw, you get a value of 14, okay? At a neutral pH, which is 7, POH is also 7, and when you add the two up, you get 14, which is pKw. So pH plus POH is equal to pKw, all right? All right, so suppose you've been given OH minus. You take the negative log of that, find out POH. All you have to do is subtract that from 14 and you get pH. So this is another way of solving pH problems. Use it if it's convenient. If you think it's more complicated, then don't. All right, so here are some pH problems to solve, okay? Some might be simple, some might require you to be able to punch in those numbers into your calculator. For example, here it's 1 times 10 to the negative 4, all right? So therefore the pH is 4 here, all right? Here it's KOH, so you're finding POH, so that's 1 times 10 to the negative 3. So POH is 3, so 14 minus 3 gives you 11. All right, so pH is 11. This is 1 times 10 to the negative 5, so pH is 5. Okay. This is 1 times 10 to the negative 1, so pH is 1. And this is 1 times 10 to the negative 6, but it's POH, all right? So POH is 6, so 14 minus 6, so pH is 8, okay? In these here, just plug it in into the calculator and then find out what pH is going to be. Now here it says find out the OH minus, all right? So strong acids, the acid concentration is equal to H3O plus, all right? So that means if I move the decimal point 4 spots here, that's 1 times 10 to the negative 4. That's my H3O plus concentration, all right? 1 times 10 to the negative 4. So therefore 14 minus the 4, therefore the OH minus is going to be 1 times 10 to the negative 10. All right, this is again strong acid. So I'll move the decimal point 5 places. So 1 times 10 to the negative 5. My H3O plus is 1 times 10 to the negative 5. So 14 minus the 5. And that should be the OH minus is going to be 1 times 10 to the negative 9. This is going to be 1 times 10 to the negative 1, and therefore the OH minus is going to be 1 times 10 to the negative 13. Okay, and then here take the Kw value and divide it by this number, and you'll get the OH minus concentration. All right, section 11.7, some of the health applications of acids and bases, especially acids. All right, stomach acid is HCl. Okay. The first stage of digestion starts in the mouth, where the complex carbohydrate like starches are getting digested with the action of amylase, the enzyme that is secreted in the mouth. But as the food travels down into the stomach, the protein digestion starts to commence. All right, so what happens is in the stomach lining you have these epithelial parietal cells, the mucus cells, and they secrete in the lining has these glands, and in that lining these cells, the parietal cells, they secrete an enzyme called as pepsin. All right, the form it secretes is called as pepsinogen, which is an inactive form. So the as soon as the protein enters the stomach, HCl is getting secreted by the parietal cells, all right? And that pepsinogen is then converted into the active form of pepsin, and then the pepsin then breaks down the protein, all right? So the optimal conditions for this digestion is a pH of 2. Okay, so that protein breakdown can start in the stomach. Okay. All right, what kind of reactions do acids undergo? Well, you know that acids corrode stuff, they eat up the metal. So when acid reacts with a metal, like a single displacement, you get a salt and hydrogen gas. Okay. When acids react with base, they neutralize each other and you get salt and water. Bicarbonates and carbonates are bases, weak bases, and so when they react with acid, one of the key characteristics is that carbon dioxide gas is released. Okay. All right, so here you have a metal, potassium, another metal, zinc, and you react it with hydrochloric acid, and it's a single displacement. The potassium and the zinc push out the hydrogen. So those two hydrogens come out as the gas, and the potassium then takes its place, the zinc then takes its place, okay, forming what is called as a salt, the ionic compound, the soluble ionic compound, and hydrogen gas comes up. So any metal, all right, magnesium and hydrochloric acid or sulfuric acid, exactly the same type of reaction mechanism. Magnesium plus H2SO4, all right, would give you Mg plus H2SO4 would give you MgSO4 plus H2 gas. Okay. All right, here what happens is exchange of dance partners. All right, so the calcium and the chlorine go together, forming calcium chloride, the salt. The two H's go together with the CO3, H2CO3, but it's called carbonic acid. It's very weak. It immediately breaks down into H2O and CO2, right? H2CO3, all right? So that's basically H2O and CO2, all right? Soda pop, that's what carbonic acid is, right? If carbon dioxide dissolves into water, it forms H2CO3, all right? Now, HCl, or any acid for that matter, can react with the sodium bicarbonate in the same mechanism. Again, the exchange of dance partners, Na and Cl, come together, and then you get H2CO3, which breaks down into CO2 and H2O. So you can try this reaction with any other acid, whether it's HNO3 or H2SO4. Okay. A neutralization reaction is where you have an acid and a base, exchange of dance partners, they form NaCl, the salt, and the H and the OH forms water. Okay, so you can have H2SO4 and KOH, just about any acid and base, and you should get salt and water. All right, so acid and base, salt and water. All right, acid is low pH, base is high pH, and then you get salt and water, which is neutral, and hence the word neutralization. All right, so what's the net reaction? Again, if you take all the AQ, break them up, where there's L, you can't, okay? You can see that the sodium ions and the chloride ions are spectator ions. So basically it's H plus and OH minus forming H2O. That's the net ionic. This is the net ionic for any acid-base reaction. All acid-base reaction is going to be H plus and OH minus forming H2O. Okay, so it says write the net ionic for the following. All right, so you can ignore the SO4 part and the Ca part. All right, it's just the H and the OH coming together. One H, all right, let's go back. So if you have one H and one OH minus, it gives you one water. All right, suppose you have two H's and two OH minuses, then you'll get two waters. That will be the net. One H, one OH, H2O. One H, but two OHs. That means you need a 2 coefficient here. So two H's, two OHs, two waters. All right. You have three OHs and one H. You need a coefficient of 3. So then 3 H's, 3 OHs, 3 waters. That will be the net. All right. So you can try these out, complete the following reactions for practice. All right, we will stop here.